Hey everyone! So recently I've posted a short video on my Instagram account showing a simple game mechanic where the player could drag some pieces of structure to build a bridge, and the post went out really well, and as I've offered myself to make a video about it, here I am. This is my first video, so it may not be so good or I may not explain things so clearly. And if that's the case, make sure to comment down here all of your questions and I'll make sure to read all of them and answer. And if you have any tips or feedbacks on how I could improve those videos, if it's too fast or it's too much code, anything actually, you can contact me like through Instagram or even commenting here. I'll also create a GitHub public repository where you can download all the code that was used on this video. And before starting the video, make sure to like and subscribe. Follow me on Instagram as I'll posting more often there than here on YouTube. And without further ado, let's go. I'm here in the Unity editor and I will briefly explain how the game mechanic looks like and how does it works. So then we can go to the code part. Here, as you can see, I have a grid that handles each structure piece on how and where they should be placed, and also reacting to the player inputs and touches. It is possible to drag structures around and place them on the grid and even change their position in case of placing them on the wrong slot. So how does it work? Well, first we have the grid game object that has a collider component attached to it, so we can react to the raycast that we'll further use to detect the placement input. And as a child of the grid game object, we can see all of the slots that can be filled with the structures component. I've named them differently because I want each one of them to be able to hold a different kind of structure type. Just like an equipment slot where you want to hold a weapon and you can't let the player store a helmet in it, for example. For those child objects, I've sorted them in a specific order so the method getComponent lists them in the correct order. This is really important if you want them to be validated at the end. Each of those child game objects are placed exactly where I want the structure game object to be placed on the scene, and all of those child objects use the same grid slot script. I will cover each of the scripts in an order starting from the bottom of the hierarchy tree up to the top, so starting from the bridge structure object up to the grid slot, then to the grid script, and so on, until I've covered all the scripts involved at the end result. So let's take a look at the bridge component. So the bridge component script is the simplest script on this project. It just holds a reference for an enum that I've created to select the type of building of the component. Let me show you. Here's the utils script that I always create to store some code that I don't want to be on a mono behavior. That means that I don't need them to be a game object on the scene. Here you can see the component type as a public enum holding a list of every type of component that we have on the project. Vertical pillar, the pillars that support the bridge, and the bridge base itself. This bridge component script should be on every component that you want to be using for the grid system and stored on the grid slot. Speaking of which, let's jump right into it. Here's where the magic and complexity starts to show up. This script should be on every child of the grid component, and it is in charge of handling the bridge component stored in it. Here we have a private bridge component reference and a public property to it. You can substitute this part of the code to be just a public reference to a bridge component. I just did it this way because it's how I'm used to do it. Down here we can see an array of component type. There is the same enum that we've used on the bridge component, and it's used to store all the component types that can be stored on this slot. So here should all the items that are able to go into this slot. Going down a little bit, we can see the setBridgeComponent method that is used to set the bridge component into this grid slot. First, it checks if there is already a bridge component in this slot by using the question mark. The question mark is basically the same as checking if the game object is null or not. So if component is null, it will not do anything. If not, the previous component will be destroyed and a new one will be set. After removing the old bridge component, it will replace with the new one and make its position to be on the position of the grid slot. That's why it's important to place the grid slot right where you want the bridge component to be placed. And last but not least, we have the empty slot method that just clears out the slot. Note that we are not destroying the game object because it will be used when the player wants to replace the bridge component that is misplaced. So we need the player to pick the component up and not destroying it. Moving on to the next part, we have the grid script that will manage and handle the multiple grid slots and the bridge component placement on each of those slots. As you can see up here, you can notice a slightly difference from the other scripts. We have the standard mono behavior as usual, but we also have this iGrid thing following it. What's that? Well, that's an interface. And it is great when you want to make sure that classes have some methods, but you don't really care about its implementation. Let me show you. As you can see here, we have only two methods and they don't have an implementation. They just have a name and the parameters they need. I will not go too deep into the interface thing in this video, but just showing you guys that this is a really useful tool. So every class that implements from this iGrid interface should implement these two methods right here, and we'll see it later that the grid script indeed implement those two methods. But for now, here we have just these signatures. Let's go back to the grid script. For the fields and properties, we just have a list of grid slots that will store all the slots that are within this grid as child of this game object. We're going to get those grid slots by using the getComponentsInChildren method that will go through each child of this grid script game object, checking if it has the grid slot component attached to it. And if it does so, it will be added on the list. If not, they will be ignored. We'll be calling this on the start method because we want the grid to start already with those references. Down here we can see the two methods from the iGrid interface, onHover and onDragRelease. The onHover method is called when the player is dragging a bridge component while hovering it over the grid. As you can see here, we have this hovering variable that stores the nearest possible grid slot on which the bridge component that is passed as a parameter is able to be placed. After getting the persistent grid slot, it sets the position of the component to be the same as the grid. Do note that we are not attaching the grid component to the slot. We are just changing its position so the player can see where the component will be placed when it releases the drag. The onDragRelease method is called when the player is hovering the grid with the grid component and releases it. It will attach the grid component into the right slot it should be. It looks really similar with the onHover method, but instead of changing the position of the game object, it calls the setBridge component on the persistent slot. Now let's take a look into that getPersistentNearestSlot method that takes in a vector tree and a bridge component as parameters. The vector tree is the position on the grid that the player is hovering, and the bridge component parameter holds a reference of the game object that the player is carrying at that point. As you can see here, the getPersistentNearestSlot uses a slightly different method syntax. That's called an arrow function. It's a function that will declare its body in line, so we don't need to create an entire method with a name and parameters on this script. You can get more information about these topics by searching link and arrow functions on Google, or, if you want to, I could cover some of the most useful and common link methods and those arrow functions in another video. But in short terms, this means that we are searching through all of our grid slots and getting all of those slots where the array of buildable types of that slot contains the building type of the bridge component that we are trying to insert into the slot. So this method will not get the slots where the bridge component couldn't be placed. After that, I'm calling an extension method that I've created to return from the list of the grid slot the nearest slot from the position that the player is hovering. The other method we have here is used when the player wants to replace a piece that was placed in the wrong position. And for that, we need to check the slot near the player input position to check if there are any bridge components set. We need to make that verification because there is the case on which the player just taps the screen on an empty grid, and in that situation we don't want anything to happen. So, this method also receives a vector tree that is the position of the player input and returns the nearest non-empty slot or null if all of those slots are empty. You can see here that we are calling 3 times the getPersistentNear slot, passing the type of the slot that we want to get. Here we are getting one of each type, and then again, using link methods, we are searching for the slots that does have a bridge component in it. The onEmptySelect is the method that calls the previous method we've talked about and returns the bridge component of that slot and also calls the empty slot from the slot we are removing the component from. The last method from this script is the currentStructure method that runs through each of the grid slot childs and returns the component type of the bridge component that's stored on each one. Note that this method will return the list of component type in the same order that the children are placed on the R hierarchy. So if you want to further check if everything is correct, make sure to put them in a specific order you want to. If there isn't any component on this slot, it will return the standard component type known. So now that we've went through all the code structure of the grid system, how do we interact with that? Well, there's an input manager script that will handle the player input and interact with the grid script. So let's dive into it. First, and one of the most important part, is this bridge component. That is a reference for the object player is dragging. I've made a private field and a public property again, but you can do it as a simple public field. Down here we have a vector tree representing the last position of the mouse on the previous frame. This is not needed, but I've made it so if the player doesn't change its mouse position, I can avoid calling unnecessary code. Now, at this point, I needed to make an workaround. The thing is that on this implementation, I needed the bridge component to be selected from an UI element, which isn't affected by the physics raycast method, that is the one used to find game objects such as the grid, bridge component, and so on. So I needed to get a reference of the event system. There's the game object that is created when you create a canvas or any UI element. And this graphic raycaster that is attached to the UI element that needs to detect the raycast. On the awake method, I search for the event system game object and store its reference. The update method is the method that runs every frame. It's important to detect the user input on the update method instead of the fixed update to avoid some unwanted problems. The input checker is the method that handles all the possible inputs of the player and we'll take a close look at it. So here we are using the input.getMouseButtonDown that returns true only on the frame that the player started the click or touch. Here I'm also detecting if the selected bridge component is null. That means the player is starting to touch and haven't selected any component. So we'll check if we need to assign a bridge component to it. To achieve that, I first try to check if the player input is colliding with an UI element using the graphic raycaster on mouse position that returns true if so, and setting the res variable with the elements that is colliding or false if it isn't. In case of colliding with an UI element, I'll try to get the preferred reference from the element that the raycast hit, and if everything runs well, I will set the selected component to be that one. In case the graphic raycaster returns false, we need to try to check if the player is trying to click on an already placed bridge component on the grid to replace it. For that, we use this method called Raycast on mouse position that works almost in the same way as the graphic one, but using physics instead of the graphic raycaster. But I'll cover those methods later. In case of the method returning true, it will set hit value as a raycast hit object that stores a lot of information about the hit. First, I'm checking if the object hit has a collider by using the question mark again, and if so, I will try to get the iGrid component. Can you see here that I'm using the iGrid instead of grid script? That's why interfaces are so powerful, because if I have another grid in the same game that I need to implement in a different way, I can create a specific script for it and inherit from the iGrid interface. And in that way, we can guarantee that it will have an implementation for the methods that interface. And then I will not need to change the input manager code to behave correctly to it. So after trying to get the iGrid component, I'll check if it's null. Because if it is possible that the physics raycast detects an object with a collider such as the background, the mountains, or other game objects that are interactable but also has a collider. Okay, so in case that the iGrid object is a null, I'll call the onEmptySelect method from the grid script that returns the nearest bridge component from the current mouse position and attach it to the selected bridge component. Now that we've finished handling the start of the input, let's go for the dragging state. Note that here we are checking if the selected bridge component is a null, which means that the player has already selected some bridge component, and also we are using the input.getMouse button that returns true on every frame that the mouse is held down, differently from the getMouse button down that returns true only on the first frame of the button or input press. So if either the selected component is a null and the player is holding the input, we would want to move the piece with the mouse position and try to attach it to the grid if the player hovers it. First, I'll check if the current mouse position is the same as the last mouse position. In that case, we don't need to go further and avoid unnecessary calls. If the mouse position is different from the last frame, then we'll keep on going and set the last position to be the current position. As we did in the last input check, we'll need to create a raycast hit object that will store the result of the raycast, and we'll call the raycast on mouse position method. If true, we'll check if the object has the grid object again by trying to get the iGrid component. If it's not null and it found the iGrid component, we'll call onHover method on the grid and let the grid script handle that. Otherwise, if we indeed hit something but the iGrid is null, we'll just update the bridge component's position to be on the cursor or touch position by using the camera.main.screen-to-word point. It's important to make sure that here the z-axis of the vector tree is the same as the distance from the camera to the grid, so that the position gets correct calculation. Here you can see that I'm repeating the same code as before, but that's because here the raycast didn't return anything, and the previous call is when the raycast indeed hits something but isn't the grid. So we need both of those calls. Now for the last input part, we'll need to handle the player releasing the input. First, I'm checking if the select component is a null. That means the player is holding some bridge component, and also checking if the mouse button up method returns true. Now, if you're a good guesser, you say that the getMouse button up returns true only on the frame that the player releases the input. And if you guess it so, you're right. Just like the mouse button down, we'll have the mouse button up. Okay, so if both of those statements are true, we need to handle the release by first again creating the raycast hit object and calling the physics raycast detecting method. If you're wondering why we aren't detecting the UI graphic raycast on those last two implementations, that's because we don't need the UI element for now. It is used for picking up the component. So one more time, we try to reach the grid point on the release position if the raycast found something, and if it does, we'll call the onDrag release of the iGrid object. Otherwise, if the player has released the object on a point outside of the grid area, we just destroy the bridge component instance and set it back to its null default. So now we'll take a look at the setBridgeComponent method that is really important for our implementation. This method receives a bridge component object that is a script that is attached to a prefab that I've made. It's almost the same thing as creating an object, reference and dragging it into the inspector or editor, but I prefer to use scripts so you have a direct reference. The method receives a script reference and creates an instance of the game object of the script and stores it into the selected bridge component, previously destroying the game object if there is another instance running. For the last part, let's take a quick look into the Raycasting method that helps us throughout the input detection. First, the physics raycaster that was used to detect raycast result on the grid. It receives a raycast hit parameter that will be changed inside the method if it hits something, and then you simply call physics raycast passing the converted mouse position into array with the screenPointArray method. Last but not least, the graphic raycaster that is used to detect the raycast on UI elements, as physics raycast doesn't detect those. So we need to make this little workaround. First, instantiate the pointer event data object, passing the event system that we've set on the awake method. Then we set its position to be the mouse position. We also need to create a raycast result list that will store all the information about the objects that the raycast hit. And then we use the raycast method passing the pointer event data and the list of the results and check if the number of results is higher than 0. For this to work, make sure that your elements on the UI aren't marked with the block raycast. If they are, it will probably be included on that list and you'll have to handle and make some sort of identification to make sure you return just the right result you want. You will also need to attach a graphic raycaster component into the UI object you want to interact with and set it up on the inspector. So that's it, guys. I hope this video wasn't too long. I've tried to cover most of the content and also avoiding the video to get too long. And again, if you think it was too fast or I didn't explain things that well, you can comment it down here, so I'll try to improve it on the next videos. Make sure to like and subscribe this video, and also follow me on Instagram, as I'll be really more active on that social media. The YouTube part will be only in case that some people want me to explain something I've posted on Instagram, so I'll bring something here. Otherwise, I think that's it, guys. Again, I will leave a link here to the GitHub page where you can download all the scripts that I've covered on this video, and please comment down here your doubts and I'll try to clear them up as soon as possible. Thank you, guys. Cheers.